Okay, so composition of functions, just a brief recap. So you're able to do the Desmos activity. The Desmos activity is going to be what I actually count as your homework or your notes assignment. So compositions of functions. This is just to kind of refresh you. Compositions and math are when we combine two things. So on that relay that you were just doing, we were working with compositions. You took f of x, so let's say f of x was the function 1 person, g of x was our function 2 person, h of x is function 3, j of x is function 4. So with the example I worked with you, we said plug in, use an input of 2. So you plug in the 2 to the f function, the first function, and you get this output, right? The output was the y value. Then you take that output and that becomes your new input. Then you get a new output and then that became your new input for h. So you input it, you get another output. You use that as the input for j, and then you get your final output. So we have combined 4 different functions together to get one final output. We could write that like, let's see, we started with f. So f, the answer that we got for f of x went into g. And the answer that we got for all of this went into h. And then the answer we got for all of that went into j. So this is like a 4 times version of a composition. What y'all have learned in Algebra 2 has been typically two compositions, 2 functions. So let's say we have f of x, and I give it to you as x squared plus 1. And we have g of x, and it's given to you as 2x plus 2. So typically you'll be given the actual functions for like f and g or two other functions. They might be named different. And what it's going to ask you to do a composition for would be something like take g and plug in f. So we read this as g of f of x. Or you could also read it as g circle f parentheses x. These mean the exact same thing. It's just like 2 different notations, 2 different ways of saying it. So g of f of x or g of f of x, you'll see it either way. What it's telling you to do is take what's on the inside of the parentheses and plug into what's on the outside. So we put f into g. Same thing here, we work our way from the right to the left. So f or x would go into f and that would go into g, essentially is what you're doing. So what does that mean? Here's how I usually set them up. If g is what we're going into, then I write g and I'll put a big parenthesis, and I saw some of y'all doing this on the relay. So I'll put a big parenthesis where x is in the g equation, and that's telling me I'm going to plug something in here. And then I keep writing the rest. So 2 parenthesis plus 2. So then where we see that parenthesis or the x, it tells us what to put in. We put f into g. So we're going to take this answer for f, x squared plus 1, and we're going to put it into g, where we wrote that parenthesis. So f went into g. Then we simplify. So here's where your algebra comes into play. Here we're going to distribute. So that would give us 2x squared plus 2. And then we still have the plus 2. So if we simplify that, we get 2x squared plus 4. And I'm not asking you to factor it or pull out your greatest common factor or anything like that. So this would just be my answer, my simplified form. So that is what you're going to see on your Desmos, how to algebraically complete a composition. This is also going to be used next class period when we look at inverse functions. You're going to need to know how to do composition functions. So make sure you practice doing it algebraically. Another way you might see it, and I'm going to do my best to sketch this graph, but you might see it graphically. So let's say I have, I'm just going to put some random points here. 4, and then 1, 2, 3, 1, 2, 3. So if I have a point here, 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 and here. So let's just say this is function f of x. And yours doesn't have to get accurate. If you're taking notes, you can just do your best to replicate what I'm drawing. Or you can go back, because I'm recording this, so you can go back and pause and count how many I did and replicate it if you want. This is g of x. So if I have a graph given, what I might show you are two functions on one graph, and it might say find, evaluate f of 1. So what that is saying is your input or your x value is 1. What's the output on the f function? So input is 1. We're going to go to 1 on the x, and you're going to follow it up to the graph where you see f. And then tell me what the y value is. So on this particular one, if we went 1 up, we'd be about halfway. So 1, 2, 2.5. I might ask you, what's g of 3? So then I go over on the x, because that's our input. 1, 2, 3. Follow it down till you hit g, and then tell me what the output is. What's the y? So that'll be -3. I might also ask you to do a composition of these. So I could say find g of 3 first, and then take that answer and find it with f. So it's basically saying work your way from the inside out. So g of 3 we just did, that was -3. So our output was -3. That now becomes the input of the new function f. So you're working your way inside out. Replace this with what you got, and then do it again to the f. So now we go f of -3, so we go 1, 2, 3 to the negative, follow it up, and my graph isn't perfect, so we'll just say it's about 2.8 on the y. Yours are going to be more accurate. I just did that rough sketch real fast. But hopefully you get the idea. So if it says f or g in front, you go on the x for the input, follow it to whichever function it tells you, and read the y for your output. Or work your way from the inside out. So that's graphically how you could see it. Last thing, what you might see is called operations with functions. So operations, mathematical operations, are plus, minus, multiply, divide, add, subtract, multiply, divide. You can do all of these operations with functions, and they're going to just show you the same way you would adding, subtracting, multiplying any other numbers. So it might say find f plus g. The way I would add two functions together, so let's use these f and g's again. I would do x squared plus 1 plus 2x plus 2. You'd combine like terms like normal and simplify. So just like adding two binomials together. You just combine like terms. Same thing for f minus g. So two functions that you're subtracting. The only difference here from adding is here you combine like terms. Here you need to distribute the negative to the g first, and then just combine like terms. Distribute that negative when you're subtracting. If it's multiplying, you might see f times g, or it might just look like fg. So that would be FOIL, double distribute, however you learned how to multiply your polynomials. Whatever method, you could have also used box. So if we were using these two for f and g, then we would do x squared plus 1 times 2x plus 2, multiply them together and simplify. So all of these are things you've done before, you just haven't really seen it in function form. Then f divided by g is the last one. This one you have to be careful of because it's division. You want to make sure that you are not dividing by a 0. So if we were to use this example, f divided by g, we have x squared plus 1 over 2x plus 2. So I could go further. This one doesn't factor anymore because it's not a difference of squares, so we would just leave it as x squared plus 1. This I could factor out of 2. Nothing's going to cancel on top and bottom because nothing is the same. So the only thing left, other than the fact that this is my answer, would be to say what x cannot be in the denominator. Because remember, you can't divide by 0, so you need to be able to tell whoever is checking your answers that x cannot be something. What would make it 0 here? So to make this whole parenthesis 0, and then 0 times 2, that would give me 0 in the denominator. This x would need to be -1. So if this x was -1, -1 plus 1 is 0, 2 times 0 is 0. We cannot have 0 in the denominator. So you have to state, anytime you have a fraction with a variable in the bottom, what the domain restriction is. What do you have to take out as part of your solutions? And that's it for the notes. So you've got the Desmos activity to do next, and it's basically over all of this. The Desmos activity is going to be compositions and graphically, and then your homework for tonight, which is on Canvas, is going to also include the operations. Questions?